start as others sign in. So we are going to continue with the data exploration and visualization, and we have Dr. Ibel Chukwu here. But before we start, a few housekeeping items. Again, make sure you sign in the attendance sheet. You can check that in the chat area, or you can also look for that in Slack. Also, today is Friday, so the evaluation form will be posted in the chat area, and I believe also in Slack. So please do well to complete the evaluation, because your feedback is very, very important to us. So without any further ado, I'll hand over to Dr. Iwafu. Ibel, it's all yours.
Thank you very much, John. Good morning, everyone. Welcome back to the second portion of Module 4. So just give me a sec to share my screen. Let's see. Okay, so that's one. All right. Okay. So yesterday we started off talking about the concept of pandas. The idea is how to utilize the different functionalities that come with pandas. We looked at things like, let me go back, see, just importing our data set, and also looked at like the different functions, such as checking for missing values, deleting, creating a subset of our data set. We also looked at things like just performing advanced Boolean expressions on our data set. But the idea is just to give you a sense of the kinds of things that can be done using the pandas data frame. Yesterday we stopped at, we concluded this workbook, or the Jupyter notebook, and I wanted us to go over the exercises on exploring pandas, but we ran out of time. So what I'll do today is start off at this portion of the exercise. Hopefully everyone at least have taken a peek at the exercise just to get a sense of what it entails. But if you haven't, not to worry, we're just going to go over it together. So basically, the idea is you're given a data set and a bunch of questions that relate to that data set. A lot of the questions are just kind of emphasizing or reiterating the concepts that we talked about yesterday. The data set is basically a data set going from the link below, from UCI. UCI, they host a lot of the clinical data sets, or if you're trying to just explore machine learning, or you're trying to explore Python, data analysis in Python, the UCI repository is a good starting point. So this is a data set that consists of medical records of 299 patients. I'm guessing de-anonymized and de-identified, no personal records. So it's 299 patients who had heart failure collected during their follow-up period, where each patient has 13 clinical features. So the features that are pertaining to the data sets are what are listed on the screen. So over here we have all the features, the age, anemia, so red blood cell, high blood pressure indication, and a whole bunch of medical features. So all we're just going to do is kind of try to look through this data set and try to identify issues with it. So the first is we are going to load the data set. So the first thing is, I don't think I put a link to the data set here, but I guess we'll just, so first thing, before we actually load the data set, we want to import the pandas module. And then the data set is df. We're storing the data set in the data frame called df. And then I'm just going to include the link of the data set. I think that's one thing. One sec. Okay, so basically, the data set is in the repository in which the link is included here. So the idea is we're reading the CSV file stored in this location. So to import a CSV file, it doesn't only have to be, let me see. It doesn't necessarily have to just be stored locally. It can be stored in a remote repository as well. So once we run this, we should have the data frame stored in the variable df. Okay, so now we can display the data frame just by executing that code. And basically, we see that we have our data frame successfully imported, or our data set successfully imported. We can basically look at the data just to get a sense of what columns are in there. And then this portion, because this data set, it's kind of already cleaned out. So a lot of the work that we do as data scientists is just kind of investigating missing data, trying to clean up the data set, and before we use it for our analysis. But in this case, somebody already did the work of cleaning the data set. So what I did was try to add more null values just so we can use it for our examples for illustrative purposes. So so if you run this code, what it does is it just adds random null values into the data. Okay, so now so the idea is now we have our data set. We don't know, we have missing values in there. We want to also check for missing values. So how do we check for missing values? So we say the data frame, the data frame, and we use the function is null, or it could be is NA, and then we also get the sum of that. So what that does, it prints out all of the columns and the number of missing values. So here we have a bunch of missing values for different columns. So one thing we can do is, because of the size of the missing values are small, one thing we can do is we could probably just delete them. So we could issue a delete command to delete all the null values. So the delete command is just saying df.drop_na, and we're only specifying the axis. Delete all of the null values in the rows. So every row that contains a null value is deleted. So you can either say axis equals row, or you can say axis equals 0. And also you want to delete in place. If you do not put this there, then you can just say df equals that, and that would do the same thing. So you're just rewriting, because every time you delete, you issue a delete or drop, what happens is it just drops, it returns a new data frame that applies that deletion, or that applies the delete function, or drops the data. It doesn't actually store it in the data frame. So in order for you to actually store it, you can basically just override it by saying df equals that, the drop command. And what this does, it basically just drops all of the null values, every row that has a null value. And then also we want to reset, because what happens is when you drop, it doesn't reset the index. So you could issue a reset index as well. So I'm just gonna, I already have all the code written out, so I'm just gonna copy them. So basically, you issue a reset index as well. So let's go ahead and run this. So now it also asks to display data types for each column. Basically, we just want to get a sense of what each column is looking like. We could either use the df.d types here, and that would just display the data types for each column, or we could say df.info. That would just give us basic information about each column. It's really up to you on which one to use. Also, it says display summary statistics of dataset. Display summary statistics of dataset df. Use the describe function. So we say df.describe, and basically what this does is just gives us kind of general information about the entire data set, like the mean of each column, the standard deviation, the max. This might not be very useful for every column, but when you have numerical columns that are not categorical, just continuous variables, you could probably this would be very useful just to see what's the minimum, what's the maximum, what's the standard deviation, you kind of get a sense of the distribution this way. Okay, so now the question asks to create a new data frame. We call this data frame df_dive blood pressure. This data frame should only consist of people within the age of 40 to 55 with diabetes and high blood pressure. So we want to filter the data set now just based on that criteria. So the age has to be within the range 40 to 55, and they have to have diabetes and also high blood pressure. So just taking a quick glance on the data set, there's a column called diabetes, which is a categorical column. You have 0 for no and 1 for yes. So it just kind of tells us who has diabetes. And also there's another column called high blood pressure. It's also categorical as well. 0 indicates no high blood pressure, and 1 indicates high blood pressure. So now all we have to do is create a new data frame based on these criteria. So first thing is we have our data frame, and then we kind of spell out those conditions. So the condition is just saying if high blood pressure is equal to 1 and diabetes is equal to 1, and also age is 40. Let me see. So age is between 40 or 55. So we have to put those conditions. Okay, so this is what the condition would look like. Let me see if I have everything correct. So the first one is our data frame with the high blood pressure column. If the high blood pressure column is 1, that means they have diabetes. And also if the high blood pressure is 1, that means they have high blood pressure. If the diabetes column is 1, that means they have diabetes. And also if the age column is greater than or equal to 40, and the age column is less than or equal to 55. So this is kind of our condition. So once we have that condition, we can basically just put that in a data frame, in the actual data frame. So we say df this. So this basically says select the records based on the condition that is specified in the data frame. So let's see. So now we call that. Okay, so I think this is the wrong column to be using here. Okay, so now we say store the results. Let's see. So this is the, okay, so. Okay, just making sure everything's correct. All right, so store the results in df underscore blood pressure. Sorry, I think there's a chat. Let me see. Can you say something about your first cell command? Let me see. Which cell command are we talking about? So, oh, are you talking about the import?
Number 3, yeah, number 3. After that, yes, this one. Yeah,
Oh,
this one.
So let's. This is just for the purpose of adding random null values into the data set. So I wouldn't worry too much about this. This is just kind of code that I put in place because the data set is cleaned up and there's no null values in there. And in order for me to kind of demonstrate the effect of deleting null values, I randomly added about 5% null values into the data set. So this is the code that does that. Yeah, so this is just kind of to the effect of kind of going through some of the things we talked about, just because the actual data set doesn't have null values. So I had to simulate just randomly inserting null values into the data set. About 5% of the data set had no synthetically included null values. So that's what this code does actually. Okay. Let me see. Okay, so we're here now, and the idea is so this is DF. So basically creating this new data frame based on the criteria that was listed in the question. Let me see, I know there would be an invalid syntax. I'm just gonna. Okay, so I might have had like a character missing or something, so I'm just going to copy and run. So basically, once we have that condition, all of the conditions met, let's see. Once we have those conditions met, we create a new data frame called DF diabetes, blood pressure, and this new data frame contains all of the values based on the condition. What we can do, we can check to see what is in there, just issuing .head, and what that does gives us the first 5. And if you notice here, all of the values for diabetes and high blood pressure are 1. So basically the idea is they have to meet the criteria that we specified. And also you notice the age is within the range. Let me see. So within the range of 40 to 55. Okay, so now just select the shape. That would give us the number of rows and columns. So we have 9 rows and 13 columns. Okay, so it says create another data frame DF platelets. This data frame should only consist of records with platelets over 200,000. So basically, this is a lot easier than the first one. All we're doing is we're just making a condition that says DF is greater than 200,000. So this is what the condition looks like. DF is greater than 200,000. And then we store that in a new data frame. So that is DF. And basically what this does, it just creates a new data frame based on that first cell command. Oh, okay. So there's a question in the chat. It says, can you elaborate on what you mean by first cell command?
That was for I think someone J0058.
Right. I think we answered that question. He kind of he was talking about this, I think. correct me if I'm wrong, if you're in the audience.
Yeah, you did it. Yeah, you answered.
Right.
Thank you, Dr. William. This is Azar.
Yeah.
Okay. Oh, good. Yeah.
Okay, so basically, once we run this command, all it does is it creates a new data frame based on the condition. And also we get the shape as well. It's kind of similar to what we did earlier. 116 rows and 13 columns. Okay, so now the idea is once we have these two results, actually, let me just, so we can see what's on this as well. So it's basically the same number of columns or the same column types, but just different rows that are returned based on the criteria. So one of this has diabetes patients and blood pressure. So they have to have diabetes and blood pressure at the same time, high blood pressure at the same time. And also they have to be within a certain age range. And the other one has their platelets greater than 200,000. So now what we want to do is we want to merge the two data frames. So the idea is we have the DF diabetes blood pressure data frame and the DF platelets. We want to merge those together. So this is a pretty easy merge because the idea is they have the same column types and they're actually of the same table. So we can use the concat function to merge the two together. So the idea is we basically just specify the two. We can use the pd.concat that we talked about last class, and then we pass in the two data frames. So we pass in platelets, and we also pass in the blood pressure. And we specify axis is, we need to pass it in as an array. And then we specify the axis is 0. So we are merging based on columns. Based on rows, not columns. So we store this in a new variable. We could call this df merge. Let's see, save. Okay, actually we call this df merge. And then we store that, say, concatenate the platelet and also the blood pressure. And then on the axis 0. Okay, so run this. Okay, so now we have another data frame underscore merge. We could just run that as well. So this data frame is basically a combination of the platelets and also the blood pressure data frames. So finally, we want to save that data frame in the export directory. So to save, we can say df platelets. So there's a function that's called to CSV. And what that does, it basically saves to a CSV file. And we specified the location in which we want to save this. So now once we run that, we should have that in the same location. Let me see, error, no search directory, exports, sorry. Actually, we should be doing df merge, not platelets. Because the merge is the resultant data frame that we created. Okay, so once we run that, it should, if there are no errors, that means we're successful. So if we head over to the export, we should see that in there, the name merge file. So this is the CSV file that we just created based on that. Again, this is comma separated value, so that's why you see every column is separated by a comma. That's what CSV actually means. So So it actually does work, and we have the data set created in this instance. So that's pretty much the kind of the exercise, pretty straightforward and easy. The idea is just to kind of reinforce some of the concepts we talked about. Okay, so I think we'll switch gears to visualization and talk a little bit about that as well. Okay, so visualization in Python is pretty much nothing different from what we have seen in other programming languages. We have the standard plots like bar charts, pie charts, histograms. We also have more advanced and complicated 3D modeling charts where you can also model X, Y, and Z axis. You could also do web visualizations where you can model your data across a map. Say you're trying to model the number of hospitalization across the United States for a specific disease. You can basically do that in Python. So Python does allow for simple visualization and very interactive visualization. So for today, we are going to look at a couple of libraries that support visualization in Python. The first one is Matplotlib. Give me 1 second. If there are, okay, it says, if there are overlapping records in both DF, will the merge DF show them twice or just once? So that's a great question. In the purpose in this, using the concat, it would basically just merge them based on the columns. So the idea is it would repeat them and not really just show them once. So yeah, it would basically just merge based on the repeated columns. So it would include them if they're overlapping. So it'd be like a different instance. You could also use, other types of merge. So there is the merge function where you could specify on what criteria you're trying to merge as well. So concatenate just means it's kind of like you're sticking two things together. You have two data frame and you're just concatenating them together. So it doesn't do the intelligence check where it kind of checks for overlap. It just concatenates. That's pretty much what that means. Okay, where was I? Okay, so the idea is with the visualization tools, you can basically plot 2D and 3D, and also some of the tools allow for interactive visualization as well. So some of the libraries we'll be looking at today is Matplotlib. We also look at Pandas. Panda data frame does allow you to do visualization right from the data frame itself, which is built on top of Matplotlib. We also have Seaborn, which in my opinion, I think it's one of the most premier visualization toolkits in Python. It's built on top of Matplotlib as well. We also look at Plotly. Plotly is for doing interactive web visualizations or for plotting graphs on the web. It's basically built in JavaScript, and you can integrate it on the web, and also you can kind of use it in your Python applications as well. All right, so starting off with Matplotlib, Matplotlib is pretty much similar to what you would get in MATLAB. The goal of Matplotlib was kind of to mirror the types of the way visualization is done in MATLAB. So that was kind of like the original idea with Matplotlib. It allows for visualization in different operating systems. So regardless of your operating system, it's a lot easier to use if you're using a Mac or using Windows. Most people don't run into any issues in terms of like generating their plots. And it's one of the widely used visualization library in Python. So before we get into the nitty-gritty of how to use the library, let's just kind of take a look at the standard plot interface. So typically you have what we call a figure. A figure is just the plain canvas. So it's kind of like just the overall outer box of this image. And inside of that figure, you have what we call axes. So think of your x-axis, your y-axis, those are what make up the axis. And then inside of it, you have the actual image. So there's the figure, and then there's the axis, and then the image. So the image consists of the labels, ticks, and basically any information pertaining to the actual graph. So when we talk about ticks or labels, this is pretty much what a graph looks like in pretty much any visualization package that you're looking at. You have what we call ticks, we have the grid. Depending on the graph, you have your graph displayed in the center. You also have your labels. If you have multiple graphs, you might want to also include labels as well. X-axis, Y-axis. So pretty standard visualization interface. So talking more specifically about Matplotlib, it's pretty much a package just like any other package that we've used so far, just like pandas. And with every package, you have to import the package before you can use it. So the first thing we do before we can use any Matplotlib is to import the package. So first off, we have to include the code that imports Matplotlib. So this is the library for that. So we're running the version 3.03. I want to say this is probably the most up to date, but please don't quote me on that. They keep producing different iterations and different versions of that. But the idea is, we're running one of the latest versions. All right, also we need Numpy just for demonstrative purposes, because a lot of the examples that we will show will just kind of use Numpy to generate this data set that we can basically visualize. So Numpy is a good way of just generating a bunch of numbers in an array just for the purpose of visualizing the data. So we're also going to import Numpy. So this portion just basically shows that it's kind of a way of okay, give me 1 sec, let me see. Why the second one as a pie plot? Okay, so that's a good question. So you can basically import, because we need the plot object, because there are two ways of let me see. There are two ways of running MATLAB. There is either you use the pie plot object directly, or you can just say MATLAB. So basically we can just say, so we want to include the pie plot. This way we can just directly call pie plot as opposed to creating an object. Let me see. There is another question. When I try to import Matplotlib, I get a notification of a dead kernel. So do you, the question is, do you have Matplotlib installed? So maybe that's actually what we should do. Instead of making the assumption, we can say, let me see, sudo pip install Matplotlib. I think this should be kind of Yeah. So let me see, restart kernel. Okay. So is this on Codio? Because yeah, if it's on Codio, everything should be functional. If it's on your own computer, you might want to make sure you have the matplotlib library installed first. You could just issue the sudo pip install matplotlib. If that doesn't work, you might want to just also restart your kernel. Okay, so we import the Numpy array as well. And this portion is just kind of saying that we want the graphs to be inline, so included in our Jupyter notebook. All right, so once we've set up all of our environment variables, such as importing all the necessary libraries, the first thing we want to do is, in order to demonstrate how this works, we want to just generate a bunch of random data. So how do we do this? We can use NumPy arrays to do that. We could also create a data frame, but for right now, we're going to use NumPy arrays. And we're going to call the line space, linear space function. What this does is it creates numbers that are evenly distributed between 0 and 10, and it creates 100 data points for those numbers between 0 and 10 that are evenly distributed. So we want to be able to create these numbers and then draw a graph based on those numbers. So, so that's what linear space does. It's called lin space. So we run this, we should have X be a bunch of numbers in an array between 0 and 10. So once we have that, what we want to do is we want to plot. So basically we want to plot that. The way to plot is pretty much, we say figure, we create a variable, and then we say figure equals plot. So basically we're using the plot alias that we had here, which is this one. And we're using that, where are we? So we say plot and we call the function figure. What that does is it creates this plot canvas and stores that in the variable figure. We don't necessarily have to do this. We can just directly call the plot function without using this. And we'll talk about why the two ways of basically calling the MATLAB function. Or matplotlib function. So we can just basically say plot this way. And if we run that, it should give us something like this, what this is basically saying is just plot a line with the x-axis being the array that we got here, and the y-axis being what we're doing here is we're calculating the sign of each number in the array. And then we want it to be a solid line. So we could either say solid line, or we can say, so if you change this, it just means the style of the line. So for right now, we're just going to go with a solid line. Okay, so now we could also do the same thing for the cosine as well. So change this to cosine, and then plot with a solid line. So you can see the graphs look different. One is a sine curve and the other is a cosine. Okay, so now it says plot the sine and cosine in the same figure. So we could say plt.plot. I'm just going to copy. And then we save that, and then we say plt.plot, and we say sine. So So what we can do is we can make one solid line and we can make the other one dashed. Okay, so the idea is one of it, so the sign is a solid line and the cosine is the dashed lines. So you can have multiple plots on the same figure. So this is kind of shows that. And then finally, if you want to save that figure, you can basically just use the save figure function with the that comes with a Matplotlib. And then you just say the plot dot save figure. So remember, the plot is this library that we called over here. So this right here is what we call the plot. We just use the alias. So plt.savefig basically just does the job of saving the figure. So if we run this, it basically saves the figure in the figures folder. So if we go to the figures folder, we should see that figure. Let's see. Where is the? Okay, so figures.myfigure.jpg. JPEG is not supported, so we can only save this. Yeah. So I guess do PNG. Okay. So the idea is if you save the plot, you should have that in your directory. Also, you should be able to open the plot. So let's say this is my figure 1. And then we have the same plot, my figure 1. That's interesting. Doesn't seem like it's. Let me see. Let's confirm the same. So PLT. I have to try to troubleshoot, see why this is, but typically if you save the figure and you load the figure, it should suffice. You should be able to load the figure back. So I'll try to troubleshoot that and see what the issue is, maybe during the break. All right. So there are actually two ways of opening or using Matplotlib library. The first way is you can either use it based on the MATLAB style, which is what we've been doing just by referencing the plot and basically add in different functions based on the plot. So in this case, we can say you basically have a plot and then you can call the figure, you can add the images, you can plot on using that plot function or using the plot directly from the Matplotlib. Let me see, does it have figure generated right before? If you can, does it save the figure being generated right before if you created multiple? Oh, okay. So the way it works, it's a stateful, and that's what we're about to talk about now. So if you use the MATLAB method, what it does is it basically creates a state. So it only saves the one that had the last state. So if you created 2 plots, it would only save the last one. So here, what we're going to save here is the last image. That's what we are supposed to save because this is a stateful way of generating plots. So if we generate these two plots, first off, we started generating this plot, and then we generated this plot. So the idea is it saves the state. So it's the last plot that we generated using this method of referencing the plot directly from the library. So the idea is when you use Matplotlib, you can basically create plots using the MATLAB style, which is what we've been doing, just referencing the plot directly. So we can create like multiple plots this way. This is nice, but the problem is it's a stateful interface. And what that means is it keeps track of the current figure. So if you create one figure and then you try to create another figure, it changes the state to that current figure that you've created. So if you try to save it, you're only saving the last created figure. So that's kind of like the drawback of the of using just referencing the library itself directly. Another way of doing it is by using the object-oriented interface. So here, what we do is we create an object called figure and AX. So this is a tuple. So this basically stores, the first one stores the figure image, and this stores the axis object. And this way we're able to kind of play around with the different plots that exist. So we can reference each plot that exists on the image directly, as opposed to just kind of having a stateful interface. But either one works. If you, in my opinion, this is kind of like what I'm used to, just using the PLT. You could also just create like these object-oriented variables that store like the axis and also the figure, and then you can kind of reference those figures yourself. So in this instance, you're generating two plots. One is on axis index 0, and the other is on axis index 1. And then you can clear those plots and you could basically replot. This way you can save the two plots directly without having to worry about what state that plot is on. So this is kind of works when you have multiple plots and you're dealing with multiple graphs in your workbook. So if we run this, so the idea is you have two different plots, and you could basically reference those two different plots directly because we saved them as objects in this case. Says to try save image, call into a variable, and then use that. Okay. All right. So yeah, I'll probably try to troubleshoot and try to fix this during the break. But thanks for the heads up. Okay. So so the idea is you can basically have you can either use the object-oriented method, or you could just use the MATLAB style, where you're directly calling the PLT method from the library. Either way pretty much works. The drawback of the first approach is that you are basically using a stateful interface. And what that means is once you change the state, you basically have to kind of redraw the plot to access the previous plots. But with the object-oriented plot, you can basically have, you could basically have direct access to the variables this way, because you're creating an object and then you can reference those objects directly. All right, so let's look into more specifics of creating the different types of plots. There are a lot of visualization plots that we can draw, but we are going to stick with the basics just because there's just a vast array of visualization plots that we can basically create. So let's start off first off with the line plots. So with the line plots, pretty easy, straightforward approach. You're drawing a line best fit, or in, say you have a function y equals mx or y equals a function of x, and you just want to plot that. That's kind of what we've been doing here, actually. So here we're kind of setting the what the figure style will look like. There are different styles, but this just basically means that we would have a white canvas that we can use, and also we could include grids in that canvas. So basically, in order to create a line plot, we're going to be randomly using the line space, or linear space rather, data set, just generating our data sets. So we generate a data set, and the data set is kind of similar to what we've seen before. And then we also generate the Y portion of the data set, which is the sign. And then we plot the figure. So here we have, we create an object called figure, and then we kind of store the figure object into the variable figure. And also we store the axis into the variable axis. And this way we can directly reference the image for this figure. So here we say ax.plot, we pass in the x-axis and we pass in the y-axis. So we can pass in y here, or we could just say np.sign x. Okay, so once you run that, you should have basically a sign graph that displays the values from 0 to 10. So you basically have the x-axis from 0 to 10, and the y-axis is basically the sign of the resultant values of x. So this is using the object-oriented method, just storing things into objects. The simpler approach is just using the PLT variable and just calling the plot function, passing in the X and the Y. It's one line of code. Pretty much draw the same thing as well. So you can see there are kind of two ways of kind of doing this. There's the object-oriented approach, and then there is the what's it called? The MATLAB-like approach. So just directly calling the library directly calling the library and calling the functions that are contained in the library. Okay, so we've kind of seen this as well. If you want to create multiple images or multiple figures in the same image, you could just use the plot function and then call the multiple. So you could use the PLT function and call the multiple images as well. So in this instance, we are plotting the sign of the X values that we had shown earlier here. And then we're also plotting the cosine of the X values that we've shown. So we have two images two graphs that we're plotting in one figure. So here we have the sine and the cosine, both in the same image. You could also have as many figures included in the same image. Okay, so you can also, I mean, there's a whole bunch of things you could play around with. You can adjust the colors as well. So here we have the same image. Now we're specifying what the line colors will look like. So here there is a parameter called the color. So the first one is the x-axis, the second one is the y-axis, and then you could have other parameters as well. In this instance, we have the color, we set that to blue, and the second image, we have the color, we set that to red as well. Well, you could specify colors not just only using the actual explicit statement. You can specify it using like character. There's short code for colors. There's also hex code as well. So in this instance, instead of saying color is blue or red, you can look for the hex code of the color. There's also a grayscale number system that kind of gives us the different types of colors. Sorry, there is a message in the chat without specifying the colors. The colors right. Yes, so yeah, so without specifying the colors, you have random assignment of colors. So if you notice here, we did not specify colors and it randomly assigned the colors. Yeah, so there are default colors that are set. So you don't have to be bogged down with specifying colors or certain attributes. Some of these things are default. But if you do want to specify color for some reason, you could also do that. So I wouldn't say randomly, they're more default assignment of colors. Okay, so so you could either specify directly with the names, or you could specify with like the hex code or subnumbering system as well. Okay, so we kind of looked at this a little bit. So yeah, you can also specify what the lines look like. If you want a solid line, you can specify that. If you want a dashed line, you can specify. If you want a dotted line, you can specify the intensity of the line, the thickness, in that aspect as well. So likewise, just like you could specify that way, you could also specify by signifying one dash means a solid, two dashes are what's it called? Our dash line, and then you could also specify a dotted line using this symbol, a dash and a dot, and then or dash dot rather, and then you could specify a dotted line using the column. So all of this can basically specify the types of lines that you want. So sometimes you might want to differentiate two graphs or two plots using like a dotted and a solid line. So these are ways you can specify those. Okay, so you could also combine the types of lines and also the color. So here we want to specify a solid green. We also want to specify a dashed cyan color. So you could basically combine the color and the lines. So basically what something looks like this, instead of specifying the color and then specifying the line style, you can basically combine two of them together. So they're just, this is kind of just going over some of the different tweaks that you can do, perform in a graph. There are a host of other ones that we'll talk about, but there is an exhaustive list of tweaks that can be made to a graph. So if you want to look at some of the other details, you can kind of go through the examples here. You have all the specifications in the, this is kind of the documentation for that. So there are the different arguments that can be used as well in the different graphs. But if you're just drawing a basic graph, all you pretty much need is the X and Y axis. You might need the label, or you might need to change the axis name. But other than that, there's still other different things you can do as well. And we'll talk about how to change the axis name and so forth. Okay, so you could also try to fine tune. You can try to fine tune the specific width of axis. So say, for example, you want the axis to be between -5 and 5, or between 1 and 10. You could basically set that as well. So in this example, we're using the plot alias from the Matplotlib library, and then we're setting the limit. So we say X limit to -1 and 11, and then the Y limit to negative 1.5 and 1.5. And what this does is it sets the limit of the graph. So you notice that the y-axis starts from negative 1.5 and negative 1.5 and 1.5, and the x-axis starts from negative 1 and 11. So basically this way we're able to kind of change the width. So by default, it starts from 0, but you can also play around with the numbers and change the width of the graph, or the limit of the graph. All right. So basically, you could pretty much do like a minimum limit and a maximum limit that way. Okay, so I think we're just going to skip over to labeling plots. So the idea is you could also include more descriptive information in your plots. So this way, you're not just only having the default values. So here we're including the title of the plot, the X label, and the Y label. So this way we have more descriptive info about the plot. So the title just means the overall title of the plot. And then your label for your x-axis is, we change that to sign X. And then for the y-axis, we change that to X. So you could basically change the values of the label just by calling the X label function and passing the value of the label in that function. You could also change the Y label and pass in the label of the function, the value of the label. So if you run that, the graph should look something like this. Okay, so so basically you could also have legends. So the idea is you could have multiple legends. So if you have multiple graphs, you want to have a way to describe those graphs. You can have a label inside of the graph that distinguishes what graph is, which of the graphs are in the graph, in the figure. So in this case, we're plotting to two graphs. One shows the the sine curve, and the other shows the cosine. So here we include a label that kind of just tells us that the green graph, or the green line, is signifying the sine curve, and then the other one, which shows that the cosine, which is the blue dotted graph, is signifying the cosine. So you could basically add the label. So that's what the label will look like, where you have the sine and the cosine. So this is kind of when you have multiple graphs included, you can kind of tell which of them are including the graphs. Okay, so this is kind of just talking about the different, so remember we have two ways of implementing the graph. It's either the MATLAB style, which is just referencing the plot, or using the object-oriented style. So what this is basically talking about is that the function calls are slightly different for the two approach. For the MATLAB, just referencing the PLT alias, that you can basically just call directly and change the labels. But for the axis, they have slightly different functions, and just kind of looking at the differences that exist between two of them. So mostly for the object-oriented approach, you basically using the function set X label as opposed to just saying X label. And also there are other differences that exist between the two approach. I think for simplicity's sake, it's the MATLAB approach is a lot more easier and straightforward than using the object-oriented approach, but both of them work either way. Okay, so let's move over to scatter plot. So scatter plot is another type of plot that is pretty much similar to a line, but instead we represent the data as dotted plots. So an example of a scatter plot will look something like this. This is kind of a line, but kind of still showing us the type of scatter plot that can exist. Instead of representing a line, we could just represent dots. So every instance of the x-axis is represented by a dot in this graph. So this is kind of a scatter plot of the sine curve. So there are different markers that we can use. This graph is just kind of showing us those kinds of markers. Make sure we still have time. Okay. This graph is just showing us the different types of markers that exist. So it doesn't only have to be just dark dotted lines. There are also other types of markers that can be incorporated into our graphs to make them a little bit nicer. So by default, it comes with the dotted, the black dots, but you can change them to any of these markers as well. Okay, so you could also use the dot scatter function. So instead of saying using dot plot, we can just say plt dot scatter and pass in the x-axis and the y-axis. And this way we're able to create a scatter plot instead of using the line or just saying plot. So we could also just call the scatter plot function, which does the same thing as we've seen earlier. So what that includes, or what you have to put in as a parameter, is the x-axis and the y-axis. So once you include those, it pretty much just creates the graph. So you actually don't even have to include anything like a marker. Once you include the x-axis and the y-axis, it kind of creates the graphs. So it creates kind of like a solid line just because the numbers are kind of spaced between each other. But I guess when you put the lines, the numbers are kind of spaced between each other. Let me see. Okay, so we also have the bar plots. So you could say plt.bar, and what that does is it creates a bar plot. X1 is not defined, sorry. So first we run the data set and then create the bar chart. So here we're just using the PLT, which is the library itself, the MATLAB library. And then we're saying plt.bar, passing in x1 and x2, which is right here. And this creates a bar chart for the data set. So the data set referenced over here, and we're just calling that using this. You could also include multiple graphs in the same bar chart. So the idea here is we have two distinct data sets. So we have x1, y1, and x2, y2, and we want to plot those together. So using the PLT alias, we can basically just create these plots in the same figure. And also we could also label them, say the X label equals bar number, Y label equals bar height, and then we plot using the title as well. Okay, so the overlap here just means that these two plots have the same values, have similar values in the x-axis. So the first plot has at the x equals 6, we have the value of y 7, and also x equals 6 here, the value of y is 2. So the idea is you can have multiple bar plots in the same figure, which we saw in the line graph. So it's kind of similar to that. You could also you could also plot histograms as well. Histograms are similar to the bar plot. They're just kind of more closer together, but you could also do the same. You could plot a histogram. So we're using this data set to generate our histogram. So here, what we use, similar to the bar chart, we use the hist function. So here we say, here we say the histogram, plot the histogram, we pass in the data. In this case, it's the array. We just pass in that array into the histogram plot, and it generates this, this histogram based on the data set. Also, we can kind of modify the histogram where we select a number of bins. So we only want 30 bins. The alpha is just saying what kind of intensity of the color should look like. Also, we say what we could also specify what the histogram type is. And also if we want like any edges in the, if we want an edge color in there. So this is kind of just playing around with the parameters of the histogram and kind of just modifying the different parameters that exist in the histogram. Also, you can have multiple histograms, just like you can have multiple line graphs, and you can have multiple bar graphs. Here, we're showing an example where we have 3 data. We generate random data from 0 to 0.8, about 1,000 of them for each of the data points. And the data should represent a normal distribution. And we try to plot that just to look at the data. So in this case, we, let me see, X3 is not defined. Okay. So in this case, we kind of just run that. And the idea is basically you can have these data sets embedded inside of one figure. And by basically specifying the alpha, we can kind of specify what the intensity is. So we're able to compare the overlap between the graphs. So the idea is when you specify the alpha, it kind of shows how transparent or how thick the graphs look. So you notice here when we specify the alpha 0.5, this looks a little lighter. When we did not specify the alpha, this looks darker. So the alpha is just kind of like the intensity of the graph. So how transparent is it? So when you have multiple graphs overlaying each other, we can kind of tell where they intersect, and we can kind of use that, or we can study that to understand, I don't know, maybe different trends that exist in the data set. But Matplotlib does allow you to do things like this, where you can kind of vary the intensity of the graph, the color intensity rather. Okay, so I think, let me see, we have a, so actually by default, the grid line shouldn't be there. So I had to run, I think I had run this earlier at some point. Let me see, you should be grid lines. Yeah, so by default, when you run the histogram, there shouldn't be a grid line. Yeah, you can specify to turn on the grid lines if you want, but by default, it should not be. Yeah. All right, so let's take about 15 minutes or 10 minutes. I don't know, William, is it 10 minutes?
Okay, so it depends on your schedule. How much are you left with?
Yeah, we still have quite somewhat to cover. So
so maybe 10.
Yeah, 10 minutes, and then yeah, we'll
and let's see what John thinks. I think John is in here. So John, is 10 okay? Yeah, Okay, we'll do 10. Let's do 10.
All
So
right,
we
sounds
found-
good. Yeah. See you on the
Okay.
next. Yeah.
Yeah. We do. Okay, and that's it's not on my written agenda, but it's on my handwritten agenda about the collaboration.
I think
John,
so. Not,
yeah, John. Yeah, I think John, your conversation is coming through. Yeah, sorry.
So do you have any feelings about the timing of the
Okay, let's see if I can mute John.
who's the admin?
Just off the top.
Yeah, he's gone now. Thanks.
Yeah, hi, William. I was.
John, yes. So I think we're on a 10 minutes.
Yeah, that
Frame. So say given a data frame, can we just directly call the plot function directly from the data frame as opposed to trying to convert it to any other instances? Pandas data frame does allow you to directly use the same Matplotlib functionalities. And these functionalities are pretty much similar to what we've seen before. So in a data frame, you could basically just generate a line plot of a specific column, or you can generate a bar chart or a histogram as well. So let's just look at an example here where we have a data frame. We generate a random data frame consisting of column A, B, C, and D. So for the purpose of just demonstrating the concept, so we have this data frame that has 0 to 100 elements or 100 records, and then has columns A, B, C, and D. So I'm just going to run this again just to make sure everything works. Okay, module random is not. Okay, so I'm just going to say import. So here, say import random. Let's see. Okay, so just give me a sec to try to figure this. See if I imported Numpy already. And then. Let's see. So it says just give me 1 second to see solutions. So database pandas, data transition. Okay, so we should
Yeah, I think you have to put a number inside the function.
Yeah, I have a solution file, so I'm just trying to
Oh, you're looking at that.
make sure you have everything set up right. Okay, so see, that shouldn't be the issue though. How much random has no. So, 1 sec, folks.
So it works at my end the way you have it.
Yeah, that's why I'm a little confused why it's not running here. I think it's more okay. I think we have to first do pip. So because we're using this Codio interface, so that's a couple of things might not be installed. Let's see, pip sudo pip install. So pandas.
Let's try pip 3.
So okay, so I'll just make sure this is not. Okay, so yeah, so I think it has something to do with the see, around okay. So I think what I'm probably going to do is okay, I'm just going to generate another pandas, another data frame. Just real quick, just so. Instead of having to switch over to my local machine.
If it doesn't work, we can just use the seed option, the set np random seed, so that it can be duplicated. This should have worked though. I'm surprised.
Yeah, just 1 sec. See, this is and then say it's troubleshooting on the fly. So, okay, so let's see if this works actually. Okay, all right. This is a size 1514. So let's just say this is size 104. ABCD. Okay, so we're back in business. Okay, so the idea is basically just generating a bunch of random data just to try out the it says, where do you get default RNG? Okay, so basically the idea here is we're just trying to generate a random data frame so we can test out some of the functionalities of the graph, of the graphing system. So the bar chart, the line graph, so calling these directly from the data frame. So here, what we are trying to do is to generate that data frame. So here we have np.random. Yeah. So here we have a bunch of random numbers from 0 to 100 that fills in the 4 columns. And then we have 100 rows. So this is what we're going to be using for our example, or to demonstrate the examples of directly calling the graphing function on our data set. Okay, so this is what the data frame looks like when you run that. I think what I'm going to, so I'm probably going to post this at the end of class. I'm going to clean this up and just post it at the end of class. But if you're doing this locally, the original code should have worked. Just you should have like the data set. But for those of you who are doing it on Codio, you probably might run into the same issue I did. So tell you what, I think I'm just going to publish. Okay. So I just pushed the update. So if you refresh, you should have the same thing that I have on here too. So this is for folks who are on Codio as well, because I'm also working on Codio. Give me a sec to set up. Okay, there we go. All right, so now we have our data set, which is a bunch of random numbers from 0 to 100. We have 100 rows and 4 columns. So we can basically directly create a line plot just using the data set. So here we want to create a line plot of just the column A. So column A is, say, we run this, and column A only consists of the values that we've seen. Let's see this. So this is what column A looks like. So we want to create a line plot based on this input data. So we can just basically factor out just column A and call the plot function. And then we can basically just say, okay, what's the style? Do we want solid or do we want dotted lines? And when we run this, we could also include the labels for X axis and the Y axis. And then we could include a title as well. So basically, you can directly call the matplotlib function from the data frame. So instead of having to pass it in, you can just call it directly from the data frame. So if we run this, it should look something like this. So this is just basically just plotting just this continuous data in plotting that using the matplotlib function directly from the data frame. Also, you could also plot scatter plots as well. So the idea here is we are plotting multiple data as scatter plots. So here we have the first one is A versus B. So the x-axis is A and the y-axis is B. And then we have another plot, which is C versus D. The x-axis is C and the, I think the x-axis is C and the y-axis D. And then we have a third plot, A versus C. So the idea is you can pretty much combine multiple plots the same way we had initially using directly from the data frame. So here we have df.plot. We're plotting a scatter plot. So we say df.plot.scatter. Here, this just specifies the size of the figure. We could reduce the size as well. We could take that out. We specify the color of the scatter plot as well. Is there a question? Is the line plot for single column values versus their indexes? Oh yeah, so that's a great observation. Yes, so it's single value versus the index. So yeah, it's 0 starts at the first index 63. So this is just plotting the line, just one simple value for the line. Yeah. Also, you can plot a bar chart. So basically, the idea is pretty similar to what we saw. Let me see if I could extend this code. So here we are just plotting the first 10 rows in the A column, and we're plotting a bar chart based on that. And here we set the line width to 2.5. The color is green. Actually, the type of bar chart is a horizontal bar chart. So if we run this, let's see, actually, this should be out. So when we run this, I think I was kind of troubleshooting earlier. So just take out the legend portion. So this is what we call a horizontal bar chart, and the idea is instead of the vertical line, the vertical lines, it's kind of slanted to the horizontal. It's still the same thing. It's just kind of different inversion. So we only plot in the first 10 because bar charts pretty much are good for categorical data. So they're not as great for continuous data. So in this instance, we just want to show how that works. So we plot the first 10 records. We can also plot multiple bar charts. So in this instance here, what we're doing is we are plotting the first 10 records of each of the columns. So we have A, B, C, and D. So we're basically saying, give me the first 10 records and then plot the bar chart. So here we say the data frame dot plot. We could take out the size. The size just signifies the size. We could take out the line width. So here we specify the kind of chart we're trying to plot. And here we specify the list, a list of the y-axis. So this is what that looks like. Here we have all of the columns. So we have a bar chart for the first 10 records in A, first 10 records in B, first 10 records in C, and first 10 records in D. So this is how you can directly access the matplotlib function from the data frame. So you don't necessarily need to pass the data frame or anything. You can just basically access it directly from the data frame. So you could call a dot plot function, and then you could basically pass in the y values. Also, we have what we call the stacked bar chart. So this is kind of like all of the columns kind of stacked together. You can also do that. This is a different type of bar chart. It's called stacked bar chart. So basically, you have the first bar chart is representing A, B, C, and D, and second one for the first 10 records. And here you notice we change the labels. So by default, it comes with numbers. You could also change the X labels. So here we have 0, 1, 2, 3, 4, 5, 6 till we get to 10. So if you look at the bottom, we change those labels from the default 0 to 9 to actual numbers. So you are allowed to do that by storing this into a variable and then calling ax.set tick labels. And this way you can pass in a list of labels. We could also include minor ticks. So minor ticks are just the individual ticks in the major ticks. So we could set that, we could turn that on. By default, they're off. So if you look at this graph, it's off over here, but when we call the function minor ticks on, that includes the minor ticks. Also, we include a grid here. So this is how we can set the grid, turn the grid on. You pass in a parameter called grid equals true in the plot function, and that will set the grid, turn the grid on. Also, you can create a pie chart. In this instance, we're creating a pie chart for the first 5 records, because obviously pie chart works best with categorical data. And in this instance, we don't have any categorical data. So if you look at the data set, where is it? If you look at the data set, it's just continuous random numbers. So we can just take the first 10 of them, or the first 5, and just plot the first 5. So this way we can create a pie chart similar to the bar chart, but the key here is changing the kind to a pie instead of a bar chart. And we can also, there is also a parameter called auto percent. So what this does is it calculates the total percent of that number in respect to the other categories. So here we see the first one is 36%. The second is, well, the first one is 13%. The second is 36%. The third is 13. The fourth is 18, and the fifth is 19% of the total value. So basically, you can pretty much perform the same types of functionalities that you have in Matplotlib, just directly from the data frame. So you don't have to pass in the values to any function. You could just basically call the plot function and then basically identify what type of graph you're trying to display, if it's a bar chart, if it's a pie chart, and basically set the parameters accordingly based on the type of graph. Okay, so let's move on to another type of graph called Plotly. So with Plotly, the idea is drawing interactive graphs. I want to say, hopefully this, so Plotly is pretty much a JavaScript library that enables Python users to create beautiful interactive web-based visualization. So a lot of the visualization or the graphs drawn here can be imported to this web-based HTML format as well. So first off, before we start, let's make sure we have all of the module imported. Let's see, sudo pip install plotly. Okay, so while we are installing that, okay, so I think that's done. So first off, we have to run that sudo pip install plotly, and then we can basically just generate our graph. So for the purpose of the examples, the Plotly does have a bunch of data sets that we can try out, so we don't have to randomly generate our own data sets. So I'm going to be using a couple of those data sets just to display some of the examples of the types of graphs you can generate using Plotly. So the first data set we're going to use is the iris data set. So this is a very popular data set. And what this shows is, I believe it's an iris plant and the different specification of the different types of iris plants. So there is like the, I guess, sepal width, sepal length, petal length. So this is kind of a data set that is used for machine learning classification, but the data set basically contains information about the iris plant. So so we're just going to be using that to display some graphs. So first thing is we import that data set. So using the px.data.iris, This is how we importing that data set, and we're storing that data set in the DF data frame. So basically, let's try to import the data set just to see, to use it for our example. So the data set has been imported to the DF data frame. So now let's just plot a simple a line graph. So the x-axis is the species and the y-axis is the petal width. Okay, so the idea is when we run that, we get a line graph where the x-axis is the petal width, the x-axis is the species, and the y-axis is the petal width. Okay, so we could also do a bar graph as well. So the idea is you have the alias. So the alias is derived from the import Matplotlib.express as px. So here we have, we store it into a variable called figure, and then we have ps.bar. We pass in the data frame, and then we specify the x and the y, and then also we specify title. So in this, we have the x-axis as the sepal width and the y-axis as the sepal length. So the x-axis here is the sepal width, and the y-axis the sepal length. And then we have our title in this case. Another interesting thing about this is you can basically download this just from the notebook. You don't have to issue a save command. You can download from the notebook. You could also zoom as well. Because this is generated in JavaScript, so it allows for a bunch of functionalities as well. We could also create a histogram. So it's px.histogram. It's the same kind of parameters as the bar chart. You have your x and your y-axis. So we're just using the column sepal length, and for y-axis, we're using the petal width. And then once you're done, you say fig, which is the variable here that stores the data, stores the graph, and we say fig.show. So this is what a histogram looks like. We could also do the same using generating a scatter plot. So it's pretty much similar. We have our x-axis, we have our y-axis, or the values for the y, the data for y and data for x. And then we have the size. So here we have our size as the petal length, and then the color is what we call species. So if we have categorical data, we could basically create a scatter plot based on that categorical data. So here we have our x as the species, and then we have the y as the petal width. And then you notice here the species is a category, and we separate those categories based on the color. So the colors is different for each species. So you notice here Setosa has a different color versus the Versi color and the other type of species. So basically we can draw a scatter plot just using the px.scatter function. So here we have the different categories and kind of the indication for each one. Likewise, we could do a pie chart. With a pie chart, it's just px.pie, and then passing in the data set. We specify what values we're using for the pie chart, and we specify the name of each component. So here we have the three species, which is the what we see on the screen, and then the data is actually the petal length for each species. So for the Virginia car, we have the specific petal length, which makes up 49.2%. We also have the other one for Setosa. The petal length is 73.2. Total petal length, which makes up 13%. And then we have the verse color, it's 213. So you can kind of see the different breakdown of the different species. Likewise, you can also do a box plot graph as well. So it's just px.box, pass in the data frame, specify what the x is and the y is. So a box plot looks something like this. So that's basically pretty much standard graphs in Plotly. You can perform similar style graphs that you will in Matplotlib in Plotly. I would say Plotly requires JavaScript. So obviously, if you have a Jupyter Notebook, you definitely do have JavaScript, or it requires you to run this in some kind of web browser, or if you run it, you must have some kind of JavaScript enabled because it runs on JavaScript. Okay, so finally, we also have another library called Seaborn. Seaborn is built on top of Matplotlib, but I would say personally, I think this is a little bit more nicer in terms of the kinds of images you can generate with this. Seaborn does allow for really nice and informative and different types of visualization, a little bit more visualization than you would typically see on like Matplotlib or Plotly. But well, I wouldn't say more, but it does allow for very nice looking visualizations. Okay, so I think we have a question. When do we need to install or import a library? How can we know? That's a good question. So whenever you want to use a library, or you want to draw any of these visualization, you want to use a tool in Python, you always have to import. But installing, on the other hand, is it's more in the terms of, have I used this library before? Then I probably have installed it. A good rule of thumb, if you're not sure, you could just reinstall it. It would basically just kind of overwrite or tell you this package has already been installed. But the idea is every time you want to use a library that does not come with the standard Python package, you must import. So like this Plotly is imported first. We installing it because we're just making an assumption that we probably don't have it on this Codio system. So we just decide to install it before we use it. So a good rule of thumb is, if you're not sure if you've previously installed this package or this library, it's always best to just install it before you use it. Even if you don't install it, it's going to tell you that you don't have this library. So you would kind of know to install it at that point. Okay, so first thing we do is let's see. Okay, so first thing we do is install the Seaborn library by using pip install. I think we might do sudo because yeah. Okay, so sudo. Change everything to sudo just because you need admin. Okay, so we have it successfully installed. So version 0.1.0. Oh, it's a good question. Does it override the previous one? Depends on the package. Some of them don't. They just tell you that it's been previously installed, and some of them just override, but it depends on the installation of the package. So here it says, I don't think we have installed it before. So here it kind of just, it looks for all of the requirements, if they've been satisfied, and then once it's done with the requirements, it installs the package and successfully installs it. Yeah. So it all depends on the library. Most of them, if you've installed it, it just kind of skips to the end, and it's the same version. It tells you already installed, you've already installed this library before. So, all right. So once we've installed that, the Seaborn library, we can then import the Seaborn library to our Python program, which is the what we're currently working on. So once we've imported that, then we, for the purpose of the examples, we're going to be using a bunch of data sets that are included with the Seaborn package. One of them is the tips data set. So what this does, it contains a bunch of tips and for different workers and different days of the week. The category, if it's dinner, lunch. So for different restaurant workers, they have the bills and the tip that was paid, the gender of the worker, and some other features that are pertaining to the worker. Okay, first rescue. So we're just going to use this data set and plot a couple of graphs based on this data set. So first off, we load, and this is a data frame, by the way. So we load this data frame into the variable called tips, and we run that. So basically, we've successfully loaded that into the variable. We can basically just peek and see the number of columns and the columns that are included in the data set. So now let's plot a distribution of the number of tips versus the category. So the time category. So either lunchtime or dinner, and we want to plot what the distribution is looking like for the number of tips across lunch and dinner. So we can do this by using one of the plots that Seaborn provides, which is called the rel plot. So rel plot allows you to plot categorical data. It allows you to plot categorical data such that you can specify what the x-axis, what category the x-axis is, and the category the y-axis is as well. So in this instance, we are specifying our x-axis to be the total bill, and then the y-axis to be the tip. So how much per total bill are people paying? And then we have the divider, which is the category we want to specify based on if it's lunchtime or if it's dinner. Also, we have what we call a hue. Hue is also another category. So when we have a scatter plot, we can specify the hue. And what that does is it basically separates the color, the different categories that exist in the scatter plots based on the category that we specified in the hue. So here we have the hue is the smoker. So based on if the waiter is a smoker or not, we can specify what the tip is per the different serving time. So if it's either lunch or dinner. So basically, when we run this, we will see a graph. We'll see basically two plots. One is for lunchtime and the other is for dinner. And you can see the differentiation between a smoker and a non-smoker. So it seems from the data, it seems like there is a lot of non-smokers in the dinner time. And then you could also see that a lot of the data is centered around I would say roughly around like 2 to 4 kind of. This is $2 to $4. So basically, and also you see it's also centered around $10 to $30 of the total bill. So you can basically do things like just kind of break the distribution based on different categories. And the way we do this is by using the rel plot. So there are different types of plots that the Seaborn library allows you to utilize. So rel plot is one of them if you want to create a scatter plot across categorical data. And also we can also use what we call the disk plot. So the disk plot basically allows us to do something similar to the rel plot, but instead of that, we're kind of drawing a distribution, which is basically a kernel density function. It allows us to see how the distribution looks. If it's skewed to the left or skewed to the right, we can kind of take a note of that just by creating this distribution graph. So here it's kind of similar to what we've seen here, but here what we're doing is we are, give me 1 second, see. Okay. So what we're doing here is we are displaying the total bill and basically the total number of people that paid a certain amount for the different times. So if it's in the lunch time, we have what the total bill is looking like for lunch, and then for dinner, we have the total bill and then the number of people that paid a specific amount. So just looking at the graph, you can see that for dinner, mostly centered around $15 to $20, and also for lunch, kind of around the same, but not quite. But this kind of gives us a sense of what the distribution is looking like. We can basically draw that. This is just kernel density estimation. So what that means, it's kind of giving us the distribution. So we can look at the overall distribution. Is it skewed to the left or skewed to the right? So if I run this and take out the KDE, you don't have that kind of normal distribution curve. So here, that's what the KDE basically does. It kind of gives us that curve, so we can kind of make sense of what distribution is looks like. Okay, so we also have another plot. So by the way, I kind of just we can also do the same histogram bar plot. But in addition to that, I kind of did not include that portion in here just because we've kind of shown that a lot. So we're going to look at other types of graphs that we can perform using the scatter plot. So in addition, we could also have the cumulative density plot. So this is kind of like using the cumulative density function as well. So this kind of just shows the cumulative proportion based on the lunch and dinner as well. And it's broken down into 2 categories. We have the smokers and the non-smokers. Also, we have what we call a violin scatter plot. So instead of having like the typical scatter plot, there is what we call a violin plot in Seaborn, and it allows us to show, it's kind of like a scatter plot, but instead of a scatter plot, it kind of looks like a violin. And we could basically generate these kinds of plot using the cat plot. So here we are generating a cat plot based on the data set, the TIPS data set, and we are passing in, we're specifying the kind to a violin plot, and the x-axis is the day. So the category day and the y-axis is the total bill. We also have a hue here, which is smoker, which splits the data based on smoker and non-smoker. So if we run this, it pretty much just generates kind of like a scatter plot based on the different days in the data set, and also categorize it based on the hue, which is either if the waiter is a smoker or a non-smoker. Okay. Also, we can also do something interesting, which is we want to do a grid visualization. Let me see, smoker. Yeah, right. Yeah, it's an interesting observation. Yeah, so these kinds of data set just or this kinds of visualization allow for those kinds of quick observation where you can kind of see what the bill looks like and who provides like more tips or the other. Okay, so you could also have what we call a multi-dimensional plot, and what this is doing is just doing an n by n plot where we plot each of the features against each other. So it's kind of an n by n grid such that every feature contained in the data set is plot against the other features. So here we have sepal. So by the way, we're going back to the iris data set. So I kind of switched back to the iris data set. We could do this with the tips data set as well. So here we have sepal length and then sepal width, petal length, and petal width. And then we also have our x-axis where we have sepal length, sepal width, petal length, petal width. And the idea is you can do a quick plot against all of the features. So it's kind of an n by n grid where each feature is plot against each other. And it gives you kind of a nice visualization where you can kind of observe the differences between features. And in this case, we say hue is the species. So the hue is always a categorical data. So in this case, we have 3 species like we've seen earlier. So here we have 3 species, and we basically plot each feature against the other feature. So this kind of gives us a nice way of observing all of the features, looking at the differences between each other, each feature. And this is done using a pair plot. So a pair plot is a way of getting kind of a graph against each feature. And you can specify the data frame here. Inside of the pair plot, you specify the hue and you can specify the height, but most of those things are default. You don't have to specify the height. Okay, so no, it's not. So I'm just responding to the comment. So it's not necessary. You don't have to put that at the end. You could take that out. It's still going to execute. Yeah. Okay. So let's move forward. So we could also use another type of. So this is just, there's a ton of visualization, and this is why Seaborn, in my opinion, is a little bit more more detailed in terms of like the types of visualization you can perform. So it allows for a different wide array of visualization techniques. So you probably see more types compared to the rest, like Matplotlib or Plotly. Personally, I use Seaborn a lot. So also we have what we call the Facet Histogram. So Facet Histogram is pretty much just plotting kind of a categorical data versus another categorical data. We can kind of see what that distribution looks like. So here we are going back to the tips data set, And the idea is we want to see what the give me one sec. So first one, okay, right. So we basically want to see what the total tips are looking for the different categories, like the percentage of the tips are looking like for the different categories, be it dinner or lunch, and also versus the gender, so male and female. So here we create a new data frame called the df_tips. And basically what that is a percentage of the total tip. So how much percentage is that tip compared to the total bill? And that is a new column that we include in our tips data frame. So here we have tip percent right here. So we can see, depending on the total bill and tip, we see if that's a 5% tip or it's a 16% tip. So now we can perform what we call a phase grid, where we have multiple categorical data. We can plot those categorical data against each other. So in this instance, we plot in the phase grid using the data frame, and we specify what the row is. So in this case, the row is our, so this is the row category. So we have the gender, the sex as the row category, and then we have our column category as the time. So if it's lunch or dinner. And then we basically plot based on that information, but instead we use the output is the tip percent. So we have our tip percentage, where from 0 to n, and then it's segmented based on the lunch or dinner, or based on the gender, male or female. We could also plot box plots. We've kind of seen this earlier. You could also do a box plot in Seaborn. So here we are plotting based on the total bill versus the days. And also we have a hue here where we separate based on the gender. So this is kind of similar to what we've seen before. You could also generate a box plot, but we use what we call a factor plot to generate a box plot. So Seaborn also has a kind of interesting, unique visualization that is called a joint plot. So in this instance, we're generating a scatter plot mixed with a histogram. But here you can kind of see that we have a scatter plot, and then we can basically dial into the specifics of the scatter plot and see what the distribution looks like for the x-axis and the y-axis. So here you see that the scatter plot is highly concentrated in this region. And then you see there's high number in that region. So it's just saying highly concentrated, in a couple of regions. For the y-axis, it's also highly concentrated. So what it means is we have a lot of people that tip in this area that paid $10 to $15 and also tipped a certain amount. I think it's about $3 or so in this area. So this kind of gives us a kind of way of visualizing the data set and kind of zooming into the x-axis and the y-axis. This is known as the joint distribution. Or joint plot rather. So you could basically plot the total bill and tip using this, this joint plot. Also, Seaborn allows us to use the heat map. So heat map is kind of similar to this, where you have the varying color distribution, shows highly concentrated values, and as the color fades away, it shows you don't have a lot of data points in that region. So for the heat map, we are using another data set that signifies the total flights. So we load this data set. This data set contains the year, month, and number of passengers of basically flight records for different years. So we rearranged that data using the pivot. So this way we're able to display the number of years in the columns and then display the months in the rows. So with this, we generate a heat map. So this heat map basically shows the number of distribution for each year given the months. So since we created a different type of data frame, we are able to view or visualize what the total number of passengers are per different months based on the years. So you would notice here that in the 1960s, we have a high concentration of passengers around July and August. And also you notice we have some also in, we also have a few in the 600s as well. But what the heat map basically does is it gives us a way of visualizing the intensity or the total number of a particular data based on a color range. So you notice the lower the number, the more yellow the color looks, and the higher or the more concentrated the number, the bluer the color looks. So here we have about 600. So if it's close to 600, you see it's darker blue. If it's close to 200, the color changes to a yellow. So the more concentrated the number, the more the more concentrated the color rather, the higher the number. So this way we're able to just take a glance at the data or the heat map to tell, okay, at what point do we have more passengers? You know, we can see, okay, in the 1960s, it's around the July, August. In the 1950s, we don't have anything close to 500 or 600 just by looking at the heat map. Okay, so I just want to quickly finish this so we can go into in-class exercise. Also, we can display correlation using a heat map. So basically what correlation means is kind of like the relationship between features. So you have two features and you want to see what the correlation of those two features are. You could basically do that. You can generate a correlation heat map to visualize these correlation numbers. So for the purpose of generating the correlation heat map, we can load in a data set. This data set contains car crashes and different features based on those car crashes per different years as well. So basically we load this data set. Let's take a look at the data set first before we actually do anything with it. So let's run this. So basically this is what the data set looks like. So when we run that, it's basically just 50 records, as we can see. It talks about, for each record, it talks about the blood alcohol level. If I guess there's a number for not distracted, how not distracted person is, insurance losses, and also state. But the idea here is we want to see if there is any correlation between the features. So the different features that exist between in this data set, we want to see if there is a correlation. So what I mean by that is, does the speeding feature affect the alcohol feature, or does the no previous feature affect the distracted feature? So if there's a change in the not distracted feature, does that also imply a change in the no previous feature? So that's basically what the correlation matrix does. So how do we create that correlation matrix? We basically just, we can just call the correlation function directly from the data frame. So here we say car crashes dot correlation, CORR, and what that does, it generates a correlation values for each feature. So it's like an n by n matrix where each feature generates a correlation value. And this is a Pearson correlation value. So you'd see there's some positive numbers, there's some negative numbers. So the closer it is to 1, the more highly correlated it is. The closer it is to 0, the non, correlated they are. And also you could have negative correlations as well. So it's a reverse, it's a direct inverse or opposite of the feature. We could also plot that correlation matrix into a heat map. So in this instance, we could just call the Seaborn.heatmap feature and pass in the correlation matrix that we generated from the correlation data. And then we could plot that. So this kind of gives us a better way of visualizing the data set such that we can look at the speeding versus the, I guess we could say speeding versus alcohol. So there is some correlation between, so the number, the cutoff, I believe it's around, is it 0.7? Please correct me if I'm wrong. But the idea is the closer it is to 1, the more highly correlated it is. And it depends on the data set. Having a threshold depends on different factors. It's not just, a hard deadline or hard threshold on every data set. But we can see, you also notice here, there is a diagonal 1s, because this is like the feature map to itself. That would be highly correlated, obviously. So that's why you have that 1 across all of the diagonals, of the diagonal rather. Also, if you look closely, you would notice the total and the no previous feature have a high correlation. So all of the totals actually do. There's also a strong correlation between alcohol and not distracted feature. So the idea is basically we can plot a heat map that kind of shows the correlation between the features. The features in this case is the columns that we're talking about. So total, speeding, alcohol, not distracted, no previous, all of those features. We can kind of draw a grid or n by n matrix that kind of maps the correlation between those features. Okay. Finally, I do want to just show an instance of what you can also do outside of just the regular plots. You can also import your data set and use a kind of a 3D interactive visualization. So Plotly does allow for a 3D visualization. And this example is just showing how that can be done. So here what we're doing is we're loading a data set that contains the total number of US agricultural exports and per the different states. And then we have kind of a code snippet that basically generates this US map. And based on the data set, we're able to kind of load that the data to display the agricultural exports for the different regions. So if you run this, what this looks like is basically a map, and it's kind of like the heat map in a sense where you can see the total numbers of exports, and you could basically click on the different states, and you can kind of get a sense of which one exports the most versus the other. So this is kind of a nice way of displaying certain kinds of information such that you don't necessarily, you can basically display it on a map, and you could kind of show the higher the color intensity, the more expensive, or the higher the total amount is. So you could basically display hospitalization rates this way, or you could display some other kinds of data. But Plotly does allow you to draw or display interactive visualizations as well. So not just only bar charts or plots, you could also do things like this as well. All right, so I think for this, we are going to just stop here for the visualization. There is a vast, wide array of information that we did not cover as well. For additional resource, you can kind of look at the link at the bottom of the notebook. I know Seaborn and also Matplotlib has a lot of visualization tools, parameters that you can use to make your experiments or your research much more effective in terms of visualizing the data. Let's, with the remaining time that we have, I want us to kind of take a look at the in-class exercise for just visualizing data. And let's take about 15 minutes. So 15 minutes would be, okay, actually, let's take about 10 minutes to just take a glance at this, and then we'll talk about the solutions once we come back. So I do want everyone to just kind of look at the exercise and kind of have a sense of how to approach the problem, and then we'll kind of talk about it once we get back after 15 minutes. Yeah. All right. I think we should go ahead and just get started with this. The idea is basically just going over the data set called COVID deaths. So it's pretty much just reported information on the total number of deaths, total number per states in the United States, and then just kind of creating simple visualizations for the information. So the first thing is we want to load the data set into the data frame. We've done this before, so it's going to be pd.read CSV. And then this is located in the dataset folder. Okay, so let's see, no such directory. No, sorry, datasets. Okay, so that should be fine. So now we do df the head, and we specify 5. That by default it's 5 records that are displayed. So you can see total number of cases, confirmed cases, probable cases, new cases, total deaths, and so forth. So it says check for null values. So df dot is null, and then some. So now we see confirmed cases has quite a lot of null values, probable cases, confirmed deaths, probable deaths. So you can see there's a bunch of null values. So in this instance, we are going to delete the null values. So here we will just basically just issue delete. So I already have this. Just gonna copy. So here we say df.drop NA axis 0. So every row that has a null value is going to be deleted. And then we want to do that in place. And also we want to reset the index once we're done. Non-type. Non-type has no attribute. Reset index. See df. Okay, so see what df is first. Okay, so that reset. Okay, so so once we drop, we also want to reset the index. So it says describe, display summary information using the describe. df.describe. So this just kind of gives us the summary statistics. So here it says visualize the total debt for any 5 states. So you could pick any 5 states. In this case, we can basically just select just 5 states and then visualize the total deaths for that. So you can just say columns equals this. So the states are in the information. Let me see first. Do df, and the states are in the state information. So we have to filter the information. Actually, we can't just plot without filtering. So in this case, we can say, only give me information if it meets the following category. So if the state is in, so if the state is in Texas, or the state is in California, or the state is in Florida or PA. So it looks something like this. So here we say if the state is New York, or the state is Texas, or state is Florida, or state is PA, or state is New Jersey. And we just only want to view the total, we just only want to view 2 columns, the state and the total debt. So we saved that into a new data frame called states. And this, we can then kind of plot the state based on the regions. So when we save this, we run this, see. So we basically have state. Let's see what state looks like. See states. So basically we have a new data frame with just the state and the total debt for each state. So now what we can do is we can basically group the information. So basically we can group that information and say states that group by the state, and then we sum that info. So actually, before we plot, let's just see what this looks like. So let's run this and just total debt and see. So group by states and then total debt. So state is PA, state is New Jersey, state and total debt. Okay. Count. Okay, so it's showing only Jersey. Let's see. Okay, so this is so we have here, we have the states equals DF, state New York, Texas, Florida, PA, New Jersey, and then we group by the states and total debts. And then here we also say plot the graph. Let's see. Okay, so this oh, interesting. Give me 1 second to try to figure out DF state, and then New York is Florida or that, and then okay, so why is it only printed in New York? So here we say state equals states that group by the state and some block spot. Why would we hold on, let me just run this over again. See. And drop it A. So here, let's just do this. Okay, so we have like that, and then here we say states equals DF. DF states equals New York, Texas, state equals Florida, or state equals New Jersey. Okay, so and then total debt. So this. Okay, so here say states. Okay, so now we say group by this, this, and this. Okay, so that should work. Group by states, sorry. So state and then group by states. Okay, so trying to troubleshoot code on the fly. So this is not, this is Jersey. Okay, so bar, great. So basically, let me see, I think there's an issue with this code. Let me just look real quick. Something cannot troubleshoot right now, but I will get back to it at some point. Let me see. So we have our states, only New Jersey. So we have total states is Jersey or total states equals Texas. It's interesting. So group by, which is weird. So I think what I'm going to do is just kind of put this here because I already have this running here, so I'm not quite sure why that one has an issue. I'll probably look over it and try to troubleshoot. But basically what I have here is pretty much what I was trying to replicate there. So the idea is basically once you group the states and then you plot, you should have something like this where you have the different states and a plot of the total cases or the confirmed cases per state. Also, the other question asked to visualize the percentage of confirmed cases for any 5 states using any of the visualization tools. So in this case, we are using a pie chart. It's pretty much the same thing, but just kind of using a pie chart. And finally, we have based on visualization types, which visualization type will be best to display the data. So this portion, I kind of took that out, but what I was trying to explain or get at here is using the 3D visualization, we might be able to better visualize this kind of data set because we have the number of states that appear. So we can basically have something similar to where is it? So we can have something similar to this where we just have the total number of confirmed cases in there. Also, we have generate a correlation heat map, explain which features are highly correlated. So, so here we just say we import Seaborn, and then we generate a correlation heat map for the features that we use, the features we use. And then based on that, we can see what the heat map looks like, which ones are highly correlated. Just taking a quick scan. We have confirmed cases and confirmed deaths, confirmed cases and total deaths. Also, let me see, it's probably, just basically taking a scan, look for numbers that are pretty much greater than like 7.7. So the higher the number, the more correlated those features are. And then finally, you just pretty much just save the figure to a location by using storing the figure in a variable called fig, and then calling the fig.save fig function. So that's pretty much all there is. I am going to update the slide, not the slides, the notebook with the solutions. So I have the solutions, but I just put them away just so that we can kind of try to think about them without looking at the solutions. But I will also post the solutions once the class is over. So you could have those and kind of go over them on your own. But that's pretty much all. I do have more material on there. So there's material for different types of visualization, also material for analyzing data set using pandas. A lot of the materials are self-explanatory, so you can kind of go over it on your own. And if you have any questions, please feel free to reach out to me. I will drop my email on the chat, so you could probably reach out to me at a later time as well. But that's all I have for today. Thank you all very much.
Thank you, Ibel, and let's show our appreciation to Dr. Nwafo for 2 days of excellent presentation on data exploration and visualization. That is a very critical aspect of data science, and you cannot do data science or very good data analytics without exploring and then visualizing the data. So thank you, Ibel, and thank you all for your participation. If you haven't signed this attendance sheet, you want to do so. Also, if you haven't completed the survey, you want to do so as well. Again, your feedback is very important to us, and then you can always check Slack for any updates on the program. Otherwise, if there are no questions for Ibel, we'll see you all again next week, and everyone has a great weekend.
The survey will be in the chat now, and also on Slack.
I have a question. I was wondering if you guys can.
You can put it in the department.
It looks like multiple people speaking. If you are not speaking, you want to mute yourself so that.
Yes, Mayako.
Hi, can you hear me?
Yes, go ahead.
Okay, I have a question about the COVID data set for the deaths. I tried to download it using on the repository, but it won't let me download it. Okay. Is there like a link you can send to me so that I can practice later?
So how did you download it? Did you?
It just shows up like a whole blank sheet of like a whole bunch of the data, basically, okay. Like all of that.
Let me see. Where are you? Is it GitHub or?
Yeah, where? I went to GitHub to try to get the data.
Okay. So everything should be in there. You shouldn't have to download the data separately. So yeah, the data is located in a folder. So you see where it says data set when you download the GitHub repo. Mm-hmm. So when you download the GitHub, you should go to module 4, and inside of module 4, you have your data set, you have the export, and you could just click on the data set. You should see that in there. You shouldn't have to do anything special to download it.
Okay, maybe. Yeah. Okay.
Maybe you can show a screen.
Well, yeah. 1 second. Let me go to the GitHub again. Hold on. GitHub. Okay. So when I go to GitHub repository, yeah.
So let me do something real quick.
So
okay, so VADSTI 2022, right? Module 4, right? And then, I would just download all of it.
See, but then it takes me to this.
Yeah. Okay, so yeah, so go back, just go back. I would probably just go click on data set at the top.
Okay.
Or
my mouse, sorry.
Go back, go to module 4.
Module 4.
Okay, go back again to VADSTI 2022. You could just click on code and click on download zip. And now you have an instance locally.
Okay.
Yeah, so now,
Of all the data sets that we have.
yeah, so now you can click on
Okay.
that, and then you can go to module 4, and you could go to data sets.
Okay, perfect.
Yeah.
Thanks.
Yeah. So that way you have all of it, basically the same thing you have on there.
Okay. Thank you so much.
No problem. All right.
All right. John, are you still there?